I'm Mike Christopher Hubeda, BSIT student, and I'm making this video for my General Chemistry Laboratory Exercise number 2, titled Kinetics and Chemical Equilibrium. Objectives. At the end of this exercise, you are expected to make and record observations, measurement and approximation, interpret and evaluate experimental observations and data. General direction. Study the two experimental setups, answer what is asked appropriately. Number 1. Identical pieces of brass were placed in two different boiling liquids for 12 hours. The graphs show how the mass of each piece of brass changed. Question number 1. Give one similarity in the change in mass of brass in both liquids. Answer. There is a constant change in the mass of the brass until 7 hours. Question number 2. Describe two ways in which the loss of mass shown in graph A is different from that shown in graph B. The answer is, in graph A, the mass of the brass is constantly decreasing at the rate of 16.66 mg per hour, with a total mass loss of 200 mg for 12 hours of brass boiling in acid solution. While in graph B, the mass of the brass is constantly decreasing at the rate of 0.03 mg per hour, and it stops decreasing at 8 hours of time. The total mass loss in graph B is 0.19 mg for 12 hours of brass boiling in basic solution. List 3 different safety precautions that are needed in doing this investigation. Number 1. Study the safety procedure before the experiment starts. Check all the equipment and chemicals to be used. Also prepare first aid kit in case of emergency. Number 2. Wear proper and safety clothing and protection like gloves, laboratory gown, face mask, goggles, etc. while doing this exercise. Number 3. Do the experiment safely by following the safety procedure. Also ask for assistance while doing this experiment. Handle chemicals carefully and avoid spillage or direct contact to skin. Number 2. The rate of reaction between hydrochloric acid and aqueous sodium disulfate was investigated. When these chemicals react, they form a precipitate which makes the solution go cloudy. The formation of this precipitate can be used to show how fast the reaction continues. 5 tests were done using the tools shown below. Test number 1. Using a graduated cylinder, 60 cubic centimeter of aqueous sodium disulfate was poured into conical flask. The conical flask was placed on a printed sheet of paper. 10 cubic centimeter of the hydrochloric acid was added to the solution in the conical flask, and the stop clock started. The time taken for the printed words to disappear from view was measured. Test 2. Using a graduated cylinder, 50 cubic centimeter of aqueous sodium disulfate was poured into conical flask, followed by 10 cubic centimeter of distilled water. The conical flask was placed on a printed sheet of paper. 10 cubic centimeter of the hydrochloric acid was added to the solution in the conical flask, and the stop clock started. The time taken for the printed words to disappear from view was measured. Test 3. Test 2 was replicated using 45 cubic centimeter of aqueous sodium disulfate and 25 cubic centimeter of distilled water. Test 4. Test 2 was replicated using 35 cubic centimeter of aqueous sodium disulfate and 15 cubic centimeter of distilled water. Test 5. Test 2 was replicated using 10 cubic centimeter of aqueous sodium disulfate and 20 cubic centimeter of distilled water.